Hey, back again to continue my cracking tutorial. I'm going to just show you another couple basic ways to crack the same login file or protection scheme that we developed last time. Let me just show you again what it was. One way to program called login is password protected. Wouldn't let you have access unless you put the right password in, which was power. So now it's authorized. And if you remember, what we did was we actually debugged the login program, set a breakpoint on fgets, and what we did was we figured out where the string compare is being made, and we saw the conditional jump where it checked to see the passwords are correct, and what we did was we knocked that conditional jump out, effectively removing it from the program execution flow, so that no matter what password you put in, it was always valid. So we basically took out that whole branch of bad code where you wouldn't have access. I'm going to show you a much easier way to actually crack that program, and then we're going to look at how to actually improve the program so that it's not so easily defeated by this method, and then we're going to see how to crack that. So real quick, there's actually a program on Linux called strings. I'm sure a lot of you have heard of it. All it does is it'll actually go through your binary file looking for any kind of string, string being defined as any kind of more than one byte of ASCII in a row. So if you look at the ASCII table, we're probably looking for characters that are like 0x20 down to 7D, any kind of legible character. If it finds a sequence of those, two in a row, then that's a string, and it outputs it for us. So what it does, we can run that on binaries. So we'll run it on our binary. We're going to pipe it to more. And so you see all the strings generated in the binary. Mostly they're generated by the compiler. But if you look down here, you'll see some that are actually developed by the author, which is us. And in the middle of that is power. Which again, if we didn't know this, if this program wasn't written by us, and we're just kind of blindly trying to crack it, that seems like a pretty good likelihood that that's a password. I don't know what I did there. So again, where is it? There you go. So it's clear text in the binary. So I mean, pretty easy. No assembly knowledge needed, no programming knowledge needed. But again, this is obviously super basic. It's very rare you'll find something like this in the wild. If someone's going through trouble protecting the binaries, rest assured they're not going to put any kind of plain text password in the binary. I mean, although it does happen, I've seen it happen. It's unlikely. So now let's actually improve our protection scheme, if you will, to prevent something so simple as strings being able to get the password. So let's see what we'll do here. We'll make a new variable called pass character array, which we don't know yet what it'll be. What I'm going to do is make another little program over here. All I'm going to do over here is make a program to encrypt our password. Encrypt is a strong word. It's not really. It's more obfuscating, I guess. Really quickly, I'll make that. Let's go with this. So we're going to put our password here. Power. We'll use the same password. So anyone who's not familiar with C, it's just a loop. So it says for X amount of times do this. So we're setting a variable here to 0, and as long as I, which is our variable which is 0, is less than the length of our password, increase I by 1. So that way it'll go through the whole password, loop through it. So then what we're going to do is like this. Basically we're saying give me the character in the character array at I. So the first time through would be 0, then it'll be 1, 2, 3, 4. So we'll get all the characters. And what we're going to do is on each character we're going to add the value of 2. Alright. And I messed up. I need to do something. Or I'll put it. So that's my ciphertext, I guess you call it. You know, it's basically what we're going to use our password now. And for everyone hearing my keyboard click and clank, I apologize. I'm actually working on a laptop with an integrated recording mic. I'm going to go this weekend and buy a better mic. But for the meantime, I apologize. So let's put this over here. Oops. Close this. Like that. So now, I mean, obviously, if I did this, we're in the same boat. We basically changed our password, and it's still going to be legible running strings. You can still see the password, plain text. So that's not what we're going to do. We're actually going to put our variable pass here, and we're going to same thing here, another for loop. Same exact flow control thing here. Let's see where it is. Alright. So same thing. We're going to grab each character. This time though we're going to reverse it. So we're going to subtract by 2. So what that'll do is essentially it'll just undo what we just did. It'll turn that in this string here back into power, and then it'll compare it to the entered password. So let's compile and see if it works. Make sure I make a mistake. Works. Anything else? No. And if I enter that ciphertext in, it doesn't work, obviously. Now, if you run strings on a binary, you will see the ciphertext. So you don't see the pass anymore. Now, the ciphertext it's still an information leak. It still does help the potential reverser, but we're much better off now. We're not just giving away the password. Now I'll show you how to actually defeat this. Again, this is very simple. You know, obviously you got to start somewhere. So let's see how we defeat something like this. Now, obviously the NOP, our initial NOP would still work regardless, but we're going to find out how to get the password without actually modifying the file again. So let's just run GDB. Let's set a breakpoint on main. So remember B is to set a breakpoint. Main's going to be our main entry point, our main function. We're going to run. It'll break in that main. Then I'm going to decompile some instructions here. So what that does is X is examine 40 instructions. I is for instruction at the instruction pointer. Again, remember, instruction pointer will point to the next instruction to be executed. So there's the instructions. You see it looks a little different now. Now what's going on here is it's that string processing that we're doing, where it's actually looping through our string. You see it's going to call it string length over and over, and there you see the subtracting by 2. You can actually follow that, and what you could do is just figure it out from that, figure out the password. It's not hard, but I know most of you guys probably don't really know assembly, and there's an easier way to do it at this point. We don't need to follow it. We know how the program works. We know that the first thing it does is it outputs a string saying password. So there's your puts. Then we know it gets a string, which is going to be our password. There's your fgets. Now, we don't necessarily know that it's going to call string length, but we know we can deduce that it's calling string length on our password. But what we're looking for next in the flow control, again, without knowing anything, we know it outputs a string, it gets a string, and at some point it's got to compare them. So what I'm doing now is I'm going to look for string compare, some kind of comparison function. There's none here, so when we hit enter, it'll give me another 40 instructions. I'm going to scroll up a little bit. There's a string compare. So good candidate that this is where our password is being compared. So what I'm going to do now is I'm going to put a breakpoint right on this line, 4006 CD. One thing to note too, I'm in a 64-bit environment. The way that arguments are passed, so when you pass an argument to string compare, assembly-wise, it'll pass them through registers. Registers are something like this: RDX, RSI, RAX, RD. Those are registers. If you're in a 32-bit environment trying to follow along, you'll see pushes. It's going to push them on the stack instead of passing through registers. So let's set the breakpoint. Now remember, the breakpoint's going to be right here. right before we actually call a string compare. So at this point, we know the arguments of string compare are set up. Now the arguments are going to be the value we put in and the value that's going to compare it against, which is going to be the password. And at that point, it should be decrypted. So let's run it. Continue. Sorry, C to continue. Put in the password. Doesn't really matter what we put in. We don't care. Now we break in right where we expect to break in. Now here is what we're going to examine the actual registers. So if I examine AX, oops, hello. Now that's what we put in. Now really quickly, X is examined. This time I'm putting S. That's a string. So to try and convert it to a string. Now let's look real quickly up here. Where is that string compare again? So here's it's moving RSI into RDX, RDI into RAX. So this is source index, destination index. Now RDX, if RDX holds our password, RDX is going to hold the one that we're comparing to. So let's check RDX. And there's the actual password. In clear text, unencrypted, about to be checked with ours. So that's another way, again, without actually modifying the file, if the program is a little more clever and a little harder, actually goes through the trouble of encrypting his strings somehow, you can still, at some point, generally it's going to decrypt it. And if you find that point in memory, dump the memory, you can actually see the actual clear text password, which is what we did there. So that cracks that, and it's running a little long now. I'm actually going to set up another tutorial later today, hopefully. I hope you guys liked it. I do apologize for the keyboard, and I know the mic is not the greatest. I'm working on it. Thanks a lot. Have a good day.